Welcome, and in this video, I'll be introducing you to diodes, a sometimes active, sometimes passive component that we've already seen with light emitting diodes, but there's a lot more to learn in this video. All right, so what exactly is a diode? Well, it's an active component that's sometimes regarded as a passive component that allows electricity to flow in one direction, but not in the other, a one-way street, if you will. Actually, what it does is it provides really high resistance in the opposite direction, but that is not infinite. We've already used light emitting diodes, which use some of the forward voltage and use it to emit light. The most common diodes that you'll see will have a black band on the cathode side of the diode, so you know which direction to point the diode. In this case, the cathode should be behind the anode. However, with enough voltage in the wrong way, you'll eventually hit something called breakdown voltage, where the diode no longer seems to work as a diode and starts to act like a conductor, and in some cases, a completely out of control conductor. Just like any other component, diodes have ratings, and exceeding them can result in electrical breakdown. All right, here we've got a basic graph. It indicates the forward voltage going into the reverse bias, and then eventually so much voltage basically leads to breakdown. There's also mention of how silicon and germanium diodes can vary in the voltage right there, as well as the schematic for a diode here in the corner. All right, so I mentioned breakdown and there's avalanche, but what does this all mean? Well, reverse bias is when the current is applied in the blocking direction. There's always a very tiny bit of current leakage in real world components, but you won't see that in ideal ones unless you have a model that models that. When enough current is applied in that direction, it starts to reach a breakdown point. This is where the diode no longer blocks and actually starts conducting. This can damage, if not outright destroy the diode and possibly other components in the circuit. Now, a very momentary and relatively small breakdown, like maybe a surge, might not actually result in a lasting problem, but if it continues, you eventually get the avalanche effect. The avalanche effect, sometimes people call it breakdown avalanche. It's when the reverse voltage is so high that it creates a chain reaction of electrons that keep striking other electrons. This results in rapid and sudden reverse current that will definitely damage or destroy things. Although there's actually certain types of diodes meant to work a bit more sanely with breakdown and maybe even avalanche in some interesting ways. Zener diodes are one of those examples. And here's the diode schematic symbol again. Note the line that's indicating the cathode side, as the black band sometimes does on the real thing. Now, your typical diode is known as p-n junction. Now, there are types that aren't. This is a semiconductor material. It's basically made of two layers. The N layer has more electrons, the P layer has more holes, and when the two fuse together, there's a flow of electrons from N to P. Now, when the diode is connected to electricity, that junction narrows and it allows for a flow. And of course, in the opposite direction, at least to a certain point, it's not going to allow a flow. This isn't too dissimilar from transistors, which we'll get into later. As I said, what I consider the default diode is a PN junction rectifier diode. There might be some people who disagree with that. And it's safe to say that's what we'll be using when we use diodes aside from LEDs. And if it's not that, I will let you know. Now, we've already used light emitting diodes in some of our videos, but what are they exactly? Well, all diode emits some form of light. Again, it's usually undetectable by the human eye, but in this case, it does the opposite. It's all about emitting light, and a lot of light. They actually didn't really come about properly until the 1970s, and as a result, they replaced Nixie tubes and some other display technologies. A lot of personal calculators and digital watches in the 1970s used LEDs, which were actually pretty dark to actually see in a lot of cases, but they hold a certain nostalgic charm. They have very specific ratings for very specific models where too much voltage or current destroys them. But you can also have too little where you can't see the emitted light. And of course, these are going to vary from color to model, everything. They come in a wide variety of sizes, materials, and colors across the whole Roy G. Biv spectrum. The closer it is to red, it requires less power. The closer to violet, it requires more because of wavelength. But again, specific models may have specific needs. although it can be really hard to figure out what kind of exact model you have with an LED. So sometimes you just have to treat it very generally. You do need to put a resistor in series probably because unless the power supply is like 2 volts or something, because LEDs do have ratings and they can only take so much voltage and current without exploding, or at least sizzling. As I said, if you have an LED, you don't know how to treat it, assume it can take 2 volts and 20 milliamps and it'll be really bright with that. So you might even want to tune that down if you don't want to suddenly go blind. In this case, this is the LED symbol. I think this is the only one actually used, but I may be wrong. You'll notice that it shares the typical diode symbol, but you've got two arrows pointing away from the diode, and that's what makes the difference. Now, in addition to the two typical diodes that I explained, one I would say is a rectifier, and the other is an LED. Again, you have LEDs, you have Zeners, tunnels, varactors, diacs, triacs, although a triac isn't technically one, uh, S, uh, SCRs, photodiodes, switching, fast recovery, Schottky, transient voltage, thyristors. A triac is technically a thyristor, and a thyristor isn't technically a diode, but more on that in a later video. And then avalanche, but there could be other types, and some of the types could be multiple things from this list at once. Now, right here, we have a diode example from every circuit. You'll notice by well, it's a paused animation, it's a picture, but it flows as long as the plus is leading into the anode. However, if the opposite is true, there's no flow. This is how your classic rectifier diode works. And again, this is an ideal version. And here we have another example. This time is in Falstead Circuit Simulator, circuit.js. I'm only using 1 volts in this case, but you get an idea. The one on the top is flowing, and the one on the bottom is not. I've mentioned ideal and real-world diodes, so let's take a minute to understand the difference. An ideal diode is just an incredibly simplified model that doesn't really conform to any particular real-world diodes, although it might get close enough for basic applications. There's little or no forward voltage, something that might be settable, so it just generally works in forward bias and blocks in reverse bias that stops everything pretty instantly. Again, there could be settings to kind of change this. Real world models have forward voltage, and on the reverse bias, there's always some kind of current a leak, and it limits it before it hits breakdown and avalanche. Again, these could be things you actually set in the circuit simulator too. Switching, charging, recovery times are generally instant in an ideal model, but with real world models, these all have parameters. Nothing's instant. And in fact, certain types of diodes may be preferred against others because they have better times for one of these three parameters. There's no IV characteristics, that's current and voltage, where current is 0 for negative voltage and voltage is 0 for any positive current. And generally speaking, graphs are basically just right angle corners. You can still get the various types of diodes in ideal models, LEDs, Zeners, and so on, depending on your circuit simulator. Now, let me start off with a real world model that just about anybody probably has if they have diodes, and that's the one in 4001, which is a rectifier diode. It's designed for converting AC to DC for low power applications, but you can generally use it as a pretty simple general purpose diode in a lot of cases. The forward voltage drop is about 1.1 volts at 1 amp, and it's designed to only handle 1 amp. Again, emphasis on this being low power. It'll start to work about around 0.6 volts, but it isn't guaranteed to completely work until you hit 1.1 volts. The maximum reverse voltage is about 50 volts peak or DC, or 35 volts average or AC. Exceeding this will cause breakdown and eventually avalanche. The reverse current leak is actually pretty low though, only a few microamps, which is significant, but not so much for basic circuits. And unlike an ideal diode, it does exist, but again, ideal model, you might be able to make adjustments. Switching and reverse recovery times are around 30 microseconds, which in comparison is actually considered pretty slow. So this is not meant for fast switching. Operating temperature is pretty wide, negative 55 C to 150 C, but outside that range, there's no guarantee it'll work anymore. And then the N1 4001 belongs to a family of 1N400 series, and as they go up a number, they can handle bigger voltages. But since this is a small signal diode, it really only can handle 1 amp in the entire series. You'll, if you get a diode that isn't an LED in a hobby kit, there's a good chance it'll be this one or something else from the same series. This is a simulation of a more advanced model that represents the one in 4004. In Falstad, you'll notice the numbers can be a bit different. But yeah, they're all set to 1.4 volts, which is again where it should function. All right, so we're just going to wrap things up here with a little bit of a recap. Diodes allow electricity to flow in only one direction, although the actual explanation is more complicated. They have ratings, and exceeding them causes electrical breakdown, damage, and even destruction to circuits. There are many types of diodes, but this video we really just focused on rectifier diodes or general purpose diodes or small signal diodes, whatever you want to call them, and light emitting diodes. Many diodes function because of a p-n juncture. It allows electrons to flow between the two layers when electricity is applied, but not all diodes are p-n junction. LEDs are great. They are cheap. There's huge assortments of sizes, colors, whatever you need. It's pretty inexpensive to buy a whole big box of them, varied types and sizes even. But keep in mind, they all have ratings. They all have limits. If you can consult a data sheet, that's great, but finding a data sheet for generic LEDs can be difficult. Well, until next time, have a good one.